Hi everyone. Today I'd like to introduce a powerful and increasingly popular method in scientific computing, which is physics-informed neural networks, or PINNs. Traditionally, solving physical problems like heat transfer, fluid flow, or elasticity relies on numerical methods like finite difference or finite element. These approaches are robust and accurate, but they have limitations, especially when dealing with complex geometries, sparse data, or inverse problems. They often require mesh generation, which can be a bottleneck, and they aren't well suited for incorporating experimental data directly. This is where pins come in. The key idea of PINs is to use neural networks not just as black box regressor, but as function approximators that are guided by physics. Instead of training purely on data, we train the network to satisfy the governing differential equations, boundary conditions, and initial conditions. These physical constraints are built directly into the loss function using automatic differentiation. So PIN learns the solution by minimizing the residual of the PDE rather than relying on labeled data at every point in space and time. This makes pins mesh-free, data efficient, and highly flexible. They are especially powerful when you only have limited measurements or want to solve inverse problems, like identifying unknown material parameters or missing boundary conditions. Another exciting aspect is that pins can naturally combine multiple physics. You can embed different coupled PDEs into the same network, which opens the door to modeling multi-physics systems in a unified framework. Of course, there are still challenges. Training pins can be computationally intensive, and tuning the loss balance between PDEs and boundary conditions requires care. But as deep learning frameworks evolve, and as we get better at designing architectures and sampling strategies, pins are becoming a very promising tool, not just for forward simulation, but also for data-driven discovery in science and engineering. Thank you.